So checking 2016 number 6, you got this table here. They're telling us a couple things. F and G have continuous second derivatives, which means their first derivatives are also continuous, which means they're also continuous, okay? And these are twice differentiable. And the table above gives us some values. And they want, if K is F of G, find an equation for the tangent line for K at 3. So we automatically know, y'all know this, it's Y minus something, whatever the Y value is, equals something X minus the X value. To find the Y value, you plug 3 in. So we need F of G of 3. Well, G of 3 is 6. So we need F of 6. And F of 6 is 4. So the Y value at 3 is 4. That wasn't too bad. And we also need the derivative, which would be K prime. So K prime of X is equal to, by the chain rule, derive the outside, F prime of G, times derive the inside, G prime of X. We drop a 3 into there. So we need F prime of G of 3 times G prime of 3. And F prime of G of 3, what was G of 3? We already said that was 6, right? Boom. And G prime of 3, they gave it to us. It's right here. Look how nice they are. G prime of 3 is 2. So it's F prime of 6 times 2. So we're going to find F prime of 6, which is 5 right there. So F prime of 6 is 5 times 2 happens to be 10. So the slope of my tangent line is 10. If they asked me to approximate something for K of like, I don't know, 3.8, you would plug that in for X and solve for Y. Okay? Then they give me H of X is a little blurry, is G divided by F. So they're saying, hey, young kids, do you know, get out of here, the quotient rule? And of course you know the quotient rule. Low D high minus high D low over low squared. It's so much fun to say. H prime of X is simply low D high minus high D low. What? High D low. Remember when this was difficult? Remember we learned this back in the fall and you were like, oh, calculus is so hard, and now you guys are just like experts. I feel bad for the AP test, for the beating you're going to give it. We need H prime of 1, which is F of 1, and I'm going to take these right off the table, okay? So F of 1 is negative 6. Please follow with me here. I have a tendency to mess things up here. So F of 1 is negative 6. That looks right. G prime of 1 is 8. Boom. Minus G of 1 is 2, and F prime of 1 is 3. That's all over F of 1 squared, which is negative 6 squared, which is 36. And you can just leave it like that. Okay? I'll simplify it because it makes me feel good. That's negative 48 minus 6 over 36, which is negative 54 over 36, which you can cancel a 9 out of that, boy. We can cancel, 18 out of that, right? Is that 3 halves? Negative 3 halves. There you go. But again, you can leave the answer just like this, as long as it's all multiplication, addition, subtraction, division, just arithmetic. And C might look a little scary. I'm going to do it up here. But check this out. We've seen this happen a couple times. I would not be surprised if they throw something at you like this year, where they ask you to integrate a function that just F double prime should become F prime, right? But if there's an inside function, don't let them get you. They're trying to trick you. You got to do a u du. So u is 2x, which means du is 2 dx, which means we got to put a 2 in here to handle this integral and a 1/2 out front. So this actually becomes 1/2 the integral of, whoa there, Chief, F double prime of u du. And because we're switching to u, we're going to change our limits, right? The 1 and the 3, that's what x are. But if x is 1, u is 2 times 1, which is 2. And if x is 3, u is 2 times 3, which is 6. So that's our integral. So that becomes 1/2. The integral of f double prime of u is just f prime of u from 2 to 6. So that is 1/2. I hear my young boys inside laughing, which is not usually a good sign. Might have to dip out and go yell at them. All right, but f prime of 6 is right from this table. What's f prime of 6? 5. So it's 1/2 times 5 minus f prime of 2. What's that? Is that negative 2? Looks like it. Negative 2. So that's 7 halves. Woohoo! Boy, howdy. That wasn't too bad.